All right, transformation number 2. Y equals x squared plus k. Now, I forgot at the end of that last video, I was like, oh yeah, remember how I said here that because the equation is making you add 2, you had to decrease all your x values by 2 to get the same y value? I just forgot to mention here that because the equation is minusing 2, I had to make all my x values go up by 2 so that when I minus 2, I ended up with the same y value. So in other words, to get 0, I had to go up by 2 to 2, so that 2 minus 2 is 0, 0 squared is 0. Anyway, just wanted to do a thing. And also, I just want to mention that I always treat these like zero factor properties, where if I was going to solve anything in the bracket, it changes the sign. So that's the other way I remember that this is x equals -2, it goes left. This is x equals +2, it goes right. Okay, that being said, the next transformation is actually quite a bit easier. You notice the table of values is quite a bit smaller. So again, we're going to start off just with our base parabola, where we're going to put in -2, -1, 0, 1, 2. And we're going to notice that we put in 0, we get 0 squared is 0. When we put in -1, we get -1 squared is 1. When we put in 1, we get 1 squared is 1. And when we put in -2, we get -2 squared is 4. And then +2 squared is also 4. We've got that symmetrical shape. This has a vertex at 0, 0. The axis of symmetry would be x equals 0, and there is no transformation. Let's even just graph this one too. So I'm going to put 0, 0, over 1, up 1, over 2, up 4, over 3, up 9 won't fit, so I don't need it. And I'm going to connect the dots. Then we're going to look to see what happens when we have y equals x squared plus 2. So I'm going to switch to a different color. And we're going to put in our values of x. So we put in -2. We get -2 squared is 4. 4 plus 2 is 6. We're going to plug in x equals -1. -1 squared is 1. 1 plus 2 is 3. We're going to plug in 0. 0 squared is 0 plus 2 is 2. And then we're going to plug in 1. 1 squared is 1 plus 2 is 3. Okay, there's that symmetrical shape. And then we're going to plug in 2. 2 squared is 4. 4 plus 2 is 6. All right, where's my vertex? Well, that symmetry is happening here, but instead of being at 0, 0, it's at 0, 2. The axis of symmetry is x equals 0. Let's draw it. So I'm going to go up here at 0, 2. Then I have a point at 1, 3. And I have a point at -1, 3. And if you think about that, from the vertex, I go over 1, up 1, over 1, up 1. Then let's put in the next point. When x is 2, y is 6. When x is -2, y is 6. Does the shape work? From the vertex, over 2, up 1, 2, 3, 4. So what's happened to my graph? How would you describe this as a transformation on the blue graph? Where did it go? Well, it went up 2. So I'm still getting that same patterning from the vertex. I'm going over 1, up 1, over 2, up 4, but now it's starting at 0, 2. If I go back to Desmos, I've got y equals x squared, and then we had y equals x squared plus 2. And what's going to happen if I add anything? Well, let's see. Let's go plus 3. Oh, it went up 3. My vertex is at 0, 3. If we go y equals x squared plus 4, the graph's been moved up 4. My vertex would be at 0, 4. But if you look at the table of values, let's even just pick this one, right? From the vertex, it's going over 1 and up 1 to 5. And then it's going over 2 and up 4 to 8. So from 4, up 1 to 5, from 4, up 4 to 8. So the shape is staying the same, but the vertex has gone up the x-axis. So if we go back to the note, we can even start making these generalizations. When the k value is greater than 0, you're going to have something like y equals x squared plus k. The graph is going to go up. All right, let's do the next table of values. What do you think is going to happen? So now we've got y is equal to x squared minus 2. We're going to put in the values of x and we're going to square it, but this time after we square it, we're then going to minus 2. So again, it's going to be affecting our y values. So when we look at this, we're going to go negative 2 squared is 4. 4 minus 2 is 2. Negative 1 squared is 1. 1 minus 2 is negative 1. 0 squared is 0. 0 minus 2 is negative 2. And then if I'm right, I should get this pattern again, right? But let's check it. When I plug in 1, 1 squared is 1. 1 minus 2 is negative 1. When I plug in 2, 2 squared is 4. 4 minus 2 is 2. This one has a vertex at 0, negative 2. That's its turnaround point. It has an axis of symmetry at x equals 0. And let's guess where this graph's going to go. So I'm going to plot my point at 0, negative 2. And then I can either do my basic shape, over 1, up 1, over 2, up 4, or I can just double check those points. When x is 1, y is negative 1. When x is 2, y is 2. Now, I'm a little bit, I don't know what the word is, particular, but I'm going to go over 1, 2, 3, and up 9. So even though it's not a point that we had, I just like as many points as I can just to keep my parabolic shape as good as I can get it. And then we know that the other way as well, it went over 1 and up 1 to negative 1, over 2 and up 4 to 2. And then if I was to go over 3, it would go up 9. And again, it's that symmetry across the axis of symmetry as well. So to describe this red graph has gone down 2. So we can put that down here. When the k value is less than 0, you get something like y equals x squared minus some number, and the graph will go down. What can we generalize about the location of the vertex? Well, it was the k that affected the y value of the vertex. So whatever's on the end being added is going to be the y value of a vertex. And the axis of symmetry wasn't affected. It's just always x equals 0 if k was the only transformation. So just one last thing before I leave you. This is a transformation on y, and you can tell because it is not in the bracket with the x. So this one up here, this transformation was in the bracket with x, so it affected x. It made you go left and right. This one is not in the bracket with the x, it's on the end, so it's going to make you go up and down. All right, so what about this one? Okay, if you're feeling confident, pause the video, give this one a go. If you're not feeling confident, keep watching. So we're going to graph y equals x squared minus 3. The first thing I want you to notice is that minus 3 is not in the bracket with the x. Maybe some of you will recognize that this is going to take my parabola and it's going to move it down 3. If you don't, here's where you start. I just want you to look at this. Okay, if this whole down 3 thing is freaking you out, I want you to just focus on the first thing we did. What's in the bracket with x? And since there's nothing, I get x is equal to 0, which means that the x value of my vertex is 0. And if that's where you're going to stop, that's fine. What you do then is on your table of values, put 0, put negative 1, negative 2, 1, and 2. Okay? You could then plug in these x values and solve for y. So if I plug in 0, I get 0 squared minus 3, which gives me minus 3. I would have a vertex at 0, negative 3, which some of you might have been able to tell just by looking at the equation. The x value of the vertex is 0, the y value of the vertex is negative 3. That would give you a point down here at 0, negative 3. Now again, from here, if you understand the shape of the parabola, you can go over 1, up 1, over 2, up 4, and you could even go over 3 and up 9. If you don't know what I'm talking about, just keep plugging in these values of x. You're going to have negative 1 squared minus 3, which is 1 minus 3, which is negative 2. When you plug in positive 1 squared, you're also going to get 1 minus 3 is negative 2. So my next point is at 1, negative 2. Oh, there it is, mirrored on the other side. Then we're going to plug in negative 2 and positive 2. Negative 2 squared minus 3 is 4 minus 3, which is 1. And if I put in positive 2, I get positive 2 squared minus 3, which is still 4 minus 3, which is 1. So then I'd have this point here at negative 2, 1, and positive 2, 1. And then again, like I said, if you knew the shape, you might have another point. Maybe you put another point in your table of values, but it's okay if you just do 5. Okay, I find the 7th or the 6th and 7th points just kind of keep your parabola a little bit more on point when you are sketching. Awesome. So this is the graph of y equals x squared minus 3. It's your normal parabola. Move down 3 if that makes no sense to you. It's a parabola that has a vertex with an x value of 0. And then you can find the y value and then choose 4 other x values, find their corresponding y values. The domain of this, like every other quadratic function, is negative infinity to infinity. And then this one starts down here at negative 3. So the range is negative 3 to infinity. Awesome. All right, go and practice this transformation.